Hello, I'm Clayton, and I'm the Director of Product Management of ParallelChain. Today, I have here with me Alice and Panos. We're going to have a chat about, why did we start this big project? What values are we bringing to the ecosystem? So let's begin. Why don't you two introduce yourselves?
Yeah, I'm Alice. I apparently am distinguished engineer. More concretely, I am architect of ParallelChain mainnet, broadly speaking, which encapsulates more than just the mainnet, but also a lot of the core protocols that we use to build mainnet, stuff like Hot Stuff RS, stuff like our peer-to-peer networking frameworks, and so on and so forth. I guess between the three of us, I'm the most hands-on on blockchain technology proper.
Yeah, it's fair to say. So I'm Panos, I'm the director of data science here, and I pretty much do whatever is machine learning related and biometrics. That will be my focus in this company.
And me, I mainly work on the layer 2 products of the company, namely the KYC software and parallel wallet and so forth. Today, I think we're going to have a chat about why did we start this project, right? So I think Alice, give us some insights, about the stuff that you work on every day.
Yeah, I think the long picture, I hesitate to say long because it's only been 2-3 years, but that's only for the company. But in the context of work on distributed systems, it's been decades, right? Engineers and computer scientists have been working on the broad topic, really, on how to coordinate different machines to do desirable things for almost half a century, I would say, since the 1970s. I would say, and this is more like an ex post facto justification of me being here, but I think it's the best way to look at it. The reason why I think we're here, and I'm here specifically, is because Nakamoto in 2009 really shook things up when it comes to distributed systems research, and especially work on consensus algorithms. And that's really opened the floodgates, and shown us in distributed systems. I wouldn't say distributed systems research is a stale area, but Bitcoin really showed us the full extent, or maybe the full extent of the possibilities in the design space for distributed systems.
Before we get too technical and stuff, I would like to know, is there something that you would like to achieve? Like, if everything goes smoothly, everything works out, the things you have in your head, what would you like to achieve? What is like I don't like this word a lot, but what is your dream goal here?
I'll say that my dream goal is, I don't want to be too committal, but I want a clear answer to some questions in distributed systems that I find fundamental. I think an analogy that I would make is sorting algorithms, right? Mm-hmm. When it comes to sorting algorithms, we kind of have pretty good answers for just the question, what kind of sorting algorithms I need to use? Mm-hmm. Well, essentially, whatever sorting algorithm you're going to use is going to be O log n. And in 99% of the cases,
we actually have the best possible right now.
Yeah,
with, when it comes to sorting. Right?
It's optimal, at least asymptotically. And 99% of the case, you're going to be using something like a merge sort derivative or a quick sort derivative or heap sort derivative. So 2 or 3 options that basically covers 99% of sorting as a use case, right? But in distributed systems, we don't have these kinds of single confident answers to almost as fundamental questions, or even more fundamental than sorting. Things like broadcast and agreement, state machine replication, we can't say confidently, oh, Nakamoto consensus is the best for 99% of situations.
Right. So
what I want is one answer to fundamental, or one or a handful of confident answers to fundamental distributed systems problems. And it just so happens that the blockchain space is, besides academia, the space that's working most aggressively towards this direction.
Right. So you want like a go-to tool shed of some algorithms that they can be used in distributed systems, and everyone is confident that they work.
Maybe if I were to convey it more informally, if you go to grad school, or you go to if you have senior classes in undergraduate studies as a computer scientist, consensus algorithms are taught in like the senior level classes, and or in the senior level graduate courses even. Typically in courses that have titles like topics in distributed systems.
Advanced topics
in distributed systems.
Right.
And the course descriptions are always like, oh, we're gonna talk about the cutting edge, blah, 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 and so on and so forth. I think a good litmus test for whether we've achieved my goal, and my goal is to have a confident answer for fundamental distributed systems problems, is if actually distributed system solutions will be like, instead of a senior class or a senior level graduate class, it could be like
undergraduate.
It could be an undergraduate second or third year class, and it could be in textbooks. That means the field is confident enough in our answers that we're ready to start telling them to undergraduates. That would be a good litmus test for when we achieve our goal.
Like generally speaking, it would be like you teach some stuff to the older students, to the advanced students, and then and then it changes. So it's not really formalized yet, right? Like it's not set in stone.
Yes, yeah. Oh, maybe a better analogy is, we have textbooks on algorithms that are in their 7th or 8th edition.
Yeah.
They're still getting published and people are still learning them. It's because the work has become part of computer science canon. We kind of agree that this is the way to do it. But there isn't like a 3rd edition or 4th edition book on distributed or like consensus algorithms, right? Because it's still, I wouldn't say new, but I would say we kind of, I'm not trying to make a pun, but the consensus is that we have not come up with a perfect or even close to optimal solution for a lot of the problems.
To cut like consensus algorithms slack, they're not nearly as mature as like sorting and stuff, right?
There's not nearly as much what?
Nearly as mature, like sorting exists even before computers, right? So but that would be a very interesting a nice future actually to be able to learn these things in the bachelor's. Like, I mean, why not?
You describe this whole effort of distributed system research as a big scientific project. Where does ParallelChain fit into this project?
The imagery that I have for this project in my mind, and this is not an original imagery, this is something I got from a talk by Simon Peyton Jones a few years back, is this project is kind of a snowflake. What do I mean by that? I mean, if you look at the more natural sciences, like biology and physics, at least this is the example that he gave. I don't know enough about biology and physics to tell you with utter precision or utter confidence that his analogy was accurate. But he characterized biology as a sort of, the academic field of biology is a sort of progress bar, right? Where we sort of started from nothing and then we kind of move forward in a single direction. Everybody's trying to push the progress bar forward in a single, towards a single goal. Computer science is a bit different, and I use computer science as proxy for distributed systems research, which you brought up. Computer science is more like snowflake. There isn't really a goal or a clear direction that we're pushing towards. Everybody's kind of pushing in their own direction, or everybody's in their little slice of the snowflake.
So you want to say that we're like we pick a field, we specialize in something, and we try to be very good at it instead of trying to do general stuff that they're like, okay, we just do one thing and we do it well.
Yeah, we do one thing, we do it well, but a drawback of this kind of way of working is that the little branches can get quite detached from each other.
Yeah.
And our work and their work, and by they I mean the rest of this distributed systems engineering research and engineering community, as I alluded to before, can lose cross relevance. I think one thing that's important, at least in my mind, is that we're working on pushing forward a specific attribute or a specific property in blockchain systems, but our work needs to be able to benefit the larger field eventually. And the way we do this is by making sure, at least in our programming, we try to code in a, I got this term from a blog article I read like a week ago. We try to make it like open source native. Write our components and our modules with the expectation that someone's gonna use it for a totally unrelated project, and that's going to benefit them. Yeah. And we are also going to be benefited from the modules and the components that they built. It's a sort of, I think it's like you mentioned. I characterize this whole distributed systems research shebang as a sort of academic community. But to be a good member of this academic community, I think it's a fair expectation that our code and your code can work together, and we can build on each other's strengths. I think we are on one of these spokes, one of the spokes of this snowflake. There are hundreds of other groups scattered around in different spokes, but we cross-reference each other.
So pretty much it's like you can see it. I mean, the snowflake example to me doesn't translate very well in my head. I can imagine like every science is pretty much like a tree, and we are working on our own branch, and the branch will get bigger and bigger, but it still has to benefit the tree, otherwise the branch will be too heavy, drop off or something. Okay. So it has to give back to the tree. There's no way we can a branch can exist on its own, right?
Yeah. I guess you can characterize all science like this, but I think areas of computer science are particularly
separated.
No, are particularly amenable. I always use the word amenable.
Do you think, at least in my view, I think, stemming from the different algorithms or different ways of solving the blockchain, consensus and, issues, there are many different approaches, right? So I think, at least for me, coming from the end user perspective, it is quite hard to adapt to new tools. So every time when I want to use something new in a new blockchain, I need to do a set of things that could be quite different. For example, the wallet addresses could be different. How they do gas fees could be different. How do you approve transactions and so forth could be different. So I think right now, we have all these new stuffs. It's quite important for us to use traditional software and combined with some AI technology to help our users a little bit, to help them with some critical tasks. So I think that would be the bright future in my head as well. Yeah.
The bright future will include like a combination of blockchain and AI.
Yeah, I think so.
Yeah, definitely for me as well. I mean, that's what I'm working on, right? That's part of like what the company is trying to achieve, right? I mean, we're definitely, nobody can say no to that. We're a blockchain technology company, right? But I would like to assume that we're quite machine learning heavy, and that's the way to go. Machine learning is here to stay. Since the booming of data, there is like It's unavoidable. It's unavoidable. And to be honest with you, if we can go a little bit less technical and more philosophical, I think it's unavoidable because we have, as computer scientists, this simplified version of the world that everything is binary and 0 or 1, but that's not the true. Like the real world actually exists on a spectrum. And machine learning, we kind of force it to be 0 and 1, but it makes decisions on a spectrum, right? So I think that actually models the real data, like how the world actually works, and that's why I think it starts to. Okay, maybe this will be a bit controversial if I say it, but I think machine learning AI is really taking over algorithmic AI, the one that would just follow some steps and come to a deterministic conclusion. Now, machine learning, you cannot know with 100% certainty what's going to happen, but you know that like 90 something percent of the times it's going to be correct. So we sacrificed the certainty to solve problems that not even that many years ago seemed crazy, like an algorithm, like a machine learning model could do that, like a computer could like beat people at like Go or like you name it. Chess. Yeah, chess it was pretty good even with a deterministic algorithm, but yeah, it blew it out of proportions when it comes to its capabilities.
Yeah.
Wow. But the thing is, since we're a blockchain company, how do those two, how can they work together? Okay, how can blockchain and AI work together? And pretty sure Alice would agree that this field, it's in its infant state. Like, and there is a lot of talk out there, a lot of, if I may say, marketing jargon out there that doesn't really translate to what's actually on the papers and on the technologies released. I don't know. Can you imagine? Because I think one of the biggest problems is that both blockchain and AI is not very user friendly right now. Would you agree with that? And do you think there is a way to tackle this?
I think some AI are definitely getting more and more user friendly. Even KYC is maturing to some degree of certainty. So, but yeah, it's not really friendly. Like, it's not great. Like, no one's happy having to take a photo and move their head around and so forth.
Do you think that's a problem? Do you think blockchain would actually only meet mass adoption, not when it becomes like the default in bachelor's classes, but when it becomes user friendly somehow?
Yeah, from my perspective, it can only become user friendly once we've solved its technical limitations. Maybe I keep using analogies to academia, but
I mean, it's hard not to use analogies, right?
Yeah.
These things are not, they're quite deep and technical, so it's hard not to use analogies.
I would say, okay, so if I'm a blockchain company, I want to make my product get mass adoption and sustainable mass adoption. What I would do right now is not to hire an expert in human-computer interaction. I would hire an expert in distributed systems. In 5-10 years down the line, let's think about the HCI stuff. But we're still missing some key pieces, key enabling properties.
Yeah,
I would say before we even talking about the user interface.
If I could like sum it down in layman terms, you say, let's make the thing good before we make it user friendly.
Yeah, I would say.
Right. Yeah, that's an interesting way to put it, but I don't think things are that discrete.
Yeah.
Like, I think there's always going to be a little bit of back and forth. Like, we're going to make it a little bit better, but then we also need like a little bit of people to care about it.
Yes, of course.
Right. So I don't think it's going to be, we finish this, okay, now we'll go with this. I think it's going to be a bit of a more chaotic back and forth.
Yeah, I mean, that's the difference between academia and working in industry, right? You have to, you can't just rely on research grants. You need to actually have real users and real revenue.
Maybe it's a little bit like internet back in the days, right? When you need to use the internet, you need to dial up. You need to open like a little box and you need to dial up. And then when someone calls you,
that was so annoying.
When someone calls you, the internet disconnects, and then the experience didn't get better until we have broadband, right? I think as soon as we have broadband, then there's
Clayton,
no
you're kind of
more
showing your age, that, right?
But anyway,
Yeah, but a key point, I think, if I may interject, is to aim for a user experience, a better user experience, but don't do it in a lazy way. Don't sacrifice decentralization for user experience. I think a lot of blockchain projects are guilty of this. Of course, centralized systems are always easier to make user friendly. But we're not trying to build a centralized system.
Right. Well, to be honest with you, I know what you're saying that, okay, we need to make things good, and there's a lot of blockchain systems out there. Actually, we both work on fields that they have a lot of hype, which is, it has its pros, but it also has its drawbacks, right? The pros is that people are interested, you can get funding, people get involved. If people actually care on what you do, that's important, right? But the negative is that you have like a lot of terms, as I said before, like jargon that actually doesn't really mean anything, or like people will like sell ideas that they don't actually work, or they're not as good as they claim to be. Yeah, I do think as a company, and that's what excites me the most about here, is that we don't really focus on the hype, we actually focus on problems that we try to solve. And that's why I'm quite, to be honest, one of the things I'm the proudest about is the KYC. Because everybody knows that when you try to make an account in some service, whatever, and they start asking you to move his head around and like do a backflip, it's annoying. Okay? It's there is no way around it. It's annoying, right? And you can solve this with machine learning. Okay, you can make it harder for the engineers, obviously, but easier for the user. And I think that we can bring it back to what we said before, right? That there's new technologies coming up and they're not user friendly. There are ways to make them more user friendly, and that's something we're working on. So the KYC will be one of them. And staying on, actually, it's not KYC specific problem, but one more thing that I like that we do as a company is that we try to, I don't want to say merge databases and AI, but we pair them, we make them like complement each other. Because fundamentally the blockchain is a database, okay, and machine learning is AI, you name it, is a data-hungry decision model. So we can actually make a positive feedback loop there. We get the data from the blockchain, we feed it to the machine learning model. The machine learning model makes a decision, which is a decision is more data. We feed that in the database and moving on, and bring that back to the KYC. For example, if let's say you have a user that failed 10 times to do his KYC and managed to go through on the 11th one, right? This is some data that you actually want to know. Yeah. And what's the best way of storing it? You can do it in a blockchain, right? Yeah. Like an untampered, immutable way. I don't think I think that's a great way that, as I say, they cannot really be mixed, the different fields, but I think definitely blockchain and AI can work with each other.
Like the nature of blockchain data is, better, would you say?
I wouldn't say, better and worse. It depends on the application, but it definitely has like benefits, right? It can be decentralized and it can be tampered with, and everybody, and it's transparent, right? It's out there, because I can have like a model that runs on my own server and I can do whatever, you never know what happens. Yeah, that's the idea of blockchain, right? Like it's out there for people to actually see like themselves.
More transparent AI.
Yes, I think that could also, the transparent thing actually brings it one step further. It's just not blockchain can help with the transparency of AI, not in just the decision making of the model, but the model itself. Like the model could be distributed in a blockchain, for example, and so everyone can verify it, use it, and verify it, and see that it works. And we can also, for example, machine learning models need training, they need fine tuning. Okay, these actions, like if you change the model, they can also be recorded in a blockchain, right, in a decentralized manner. So if something goes wrong along the way, then you can know exactly when and where and how it went wrong. So
Interesting. Yeah.
Reproducible.
Yeah.
Inferences. I think I don't know much about AI, but I guess I imagine if you store all the weights of a neural network on the blockchain and then you feed it the same input, it will produce the same result everywhere.
Exactly, but exactly reproducible inference. And I'm taking it one step further, that we might want to collectively change that neural network, fine tune it a little bit. Also, the changes can be there, so you can even reproduce the improvement of the AI in the blockchain. So, to be honest, this is going to sound ridiculously cliche, but I think like the combinations of how blockchain and AI work together is almost the sky's the limit. Like your imagination is probably the only limit, with a few physical limitations obviously there. But
and I guess, you know, I'm assuming you're gonna need a fast blockchain to do it, like because of the speed that you send data.
Scalability and TPS never hurt anyone.
Yeah.
And I think ParallelChain is doing pretty well with that.
Yeah.
So.
I think maybe we aren't going to run the models in smart contracts, right? We're gonna store the weights in some way in the blockchain. Maybe not the entire model, but some compact representation of it, or compact like identifier of the model's weights in the blockchain. Actually, you need maybe advances in cryptography to enable this as well.
Yeah. It's not. Yeah, and it's one of the things that sound very easy in PowerPoint if you just talk about it, but actually implementing it will be harder. But what you said about smart contracts is very interesting, and I like it that we also work on this as a company. That you say about putting the AI in the smart contract. I'm thinking about the other way as well, like checking the smart contract with AI. That because everybody can go create smart contracts, right? It would be very nice if we can tell the users of the blockchain that, you know, our AI model said that this smart contract is probably fraudulent or not. I think that's also a very interesting application that we're working on, and it would definitely benefit the users of the blockchain. This doesn't exist. I don't know anyone else who does that.
Yeah, generally, it's not a good user experience when there's a smart contract exploit, right? So,
definitely, that's horrible user experience for sure. So yeah, I actually think, we're working actively on it, that AI can help on the fraudulent smart contract detection. So, which is also very exciting, and I think, again, very cliche, it can make the crypto world a better place.
And it might help with the quality of the apps, right? Like instead of spending so much time auditing the contract, you know, the efforts, you know, could be transferred into, you know, improving other aspects of the applications, right?
Yeah.
So I think that is going to be beneficial for the ecosystem that we have, and very good.
Actually, auditing, I think, is a key word, and I'm gonna take a step here and say that I think both me and Alice will agree that machines are better at making decisions than human beings often, because they don't care. They're not sensitive. They didn't have a bad day. They can work 24/7. So, I mean, what is the consensus mechanism? Like, why do we need a consensus mechanism at the end of the day, right? Because we don't trust each other. If we trusted each other, we wouldn't need a consensus mechanism. But because you don't have to trust each other, that's the whole thing with blockchain, right? Trustless. And when you have an AI that makes decisions, I think it's the same thing. You don't have to trust a human being that might have had a bad day. You have the model that's trained on like millions of data to make a decision for you.
I wanted to say something about automated
Mm.
automated verification or validation, whatever,
You name
of,
it.
of programs, being a very general and difficult problem that
Definitely.
has been relevant way before blockchain was invented. But I think one of the benefits.
Be like
It is a very old problem, and
No.
it's a very hard problem, right? It's
be like
No,
grandmother.
my point is more like it's a very hard problem, but with the constraints of blockchains, i.e., single-threaded smart contracts with very simple, very linear logic, not that many loops, not many jumps. It's actually quite tractable. So I'll say that maybe researchers in formal verification and auditing of programs can look at applying their techniques in smart contracts first as a before we try to solve the problem more generally. It could be a good testing ground for these approaches.
yeah.
I mean, from the end user perspective, it will be the developers that are going to be using the tool, right? So it's going to be some sort of Grammarly check of the smart contract.
I don't think necessarily has to be a developer, right? Like I might want to use a smart contract. I want to certify it myself. I don't know.
So you could use the tool to look it up and see if there's any red flags.
At least that's the way I see it. It's going to be like public for everyone that want to get like a little bit of peace of mind that if I run this, my money will stay with me, or whatever transaction I want to perform.
You need to define some invariants.
Definitely.
You need to define some invariants, and the good thing about the business logic of smart contracts is that the invariants are typically quite intuitive, right? It's like you can it's something it's some variant of I don't want to lose my money. The invariant is I don't lose my money, and then you can and then you can use the automated tool to see if a sequence of calls to particular set of smart contracts always in every scenario maintains the invariant that I don't lose my money. That's another reason why I think formal verification techniques may be particularly amenable to smart contract business logic because the invariants are intuitive. It's not formal verification of things outside smart contracts like databases or like very complex parallel systems. The invariants are much more abstract. It's much harder to express to the formal verification tool. I mean, you may not have expressed the invariant properly, or maybe you forgot to express some invariants that you desire, or maybe the formal verification tool is more like a fuzzing tool. It's non-deterministic. Sometimes the audit may pass, sometimes may fail, but yeah, I wouldn't call formal verification a way to certify the correctness of a smart contract. It's to give a strong indication or a weak indication in some cases that the contract is secure or it will behave in ways that you don't expect it
That's
to
the thing though with security systems in general, right? I don't think anybody claims that a security system is 100% secure. Like you do this, you're going to be safe forever, right? It's just they're going to give you peace of mind and a certain level of security. But definitely we can provide that. We can provide it to a certain extent, obviously, using AI.
This will be the end of our discussion today. Please leave your thoughts down at the comments, and thank you very much for tuning in.